Hello, everyone. Live from my spare bedroom to yours or wherever you are. This conference from home thing is a curious thing, isn't it? I was so looking forward to being with us all together in Newcastle back in March, if that was your plan as well. Yeah, maybe next year we can do that. I'm based in Manchester. I'm a big fan of promoting tech in the North. So I was super chuffed to hear about this conference and excited to be welcome to it. And maybe next time we can meet, that'll be ace. We're all good. Just checking all the comments. Yes, brilliant. Right. So I had no idea that Sam Newman was going to do the keynote about serverless, and here we are doing more serverless. So fortunately, it seems to fit quite nicely. What Sam has done, I think, has set us up to go into a bit more detail now. So if you heard Sam's talk and thought that's pretty cool, let's do some more of that, then this, I think, should be spot on for what we need this morning. We've got about half an hour plus time for questions, I think, as well. So I am head of architecture for parts of the BBC, helping the BBC run its dozens of websites and apps. There'll be more than you probably are aware of. There's apps for kids. There's 41 different languages around the world that we support with our World Service offering. There's all kinds of stuff the BBC does. It's given how much it happens, we've got a pretty small team, and efficiency is the name of the game, right? This is public money we're spending. We've got to be as ruthlessly efficient as we can and deliver the best service we can. And so tools like serverless are just perfect for that. And we'll look a little bit about that story, how maybe that could influence your story as well, and some views on kind of how you get there in a good way, which I think builds on some of the concepts Sam was saying earlier really rather nicely. So why are we not moving to the next slide? Hey, okay, so rather interestingly, but to help prepare for this talk, so I had a bit of an online kerfuffle over the past couple of weeks. I wrote this blog post on Medium, as you do, right, about how we have moved the whole of BBC Online from our own data centers to the public cloud, mostly Amazon, but GCP, if you're interested. It's been a multi-year project. There's all kinds of stuff that's done. Lots of different people involved with a big project, and we wrote this post to go, yes, we've done it, and it's great. And got lots of nice things said about the post, which is ace. But the Register decides to make an article about this. Everyone know the Register, right? A brilliant website. Decides to make a website about this, but wanted two sides to the story. So as well as copying a lot of things I've written in that blog post, it also found some people on Hacker News who were a bit critical about it, right? And that's cool. Happy to debate that, right? Most comments were positive, some were critical, and it kind of this made for an interesting article for us. And some of the things that it called out about this was that serverless and this exuberant waste of money. Wondering why on earth we need 2,000 lambdas a second required, lambdas being the Amazon's serverless tech, if you don't know it. And this is the epitome of serverless gone wrong. And so we'll use today, if you don't mind, to kind of answer some of these challenges, right? So maybe you feel this way as well, right? Do you think serverless is a waste of money, or you're worried about the cost? Are you curious about how it scales and so on? We can kind of look at these challenges, because I think there's as Sam says, there's maybe some interesting learning journey we have to go on, and that's what we've been doing over the past few years. We found serverless to be not at all the solution to everything, but it is a really exciting solution in many cases. About half of the BBC website now involves serverless. Not entirely. We still have virtual machines, containers, because there's lots of stuff going on to power this site, but there is serverless somewhere in the stack for at least half the site, including the most significant thing we do, which is articles. We serve millions upon millions of articles every day. This left and right is what we've moved from and to. You'll notice it's pretty much the same, right? Because this was not a rethink of our website. It was a rebuild on the cloud, moving from our own data centers, where it's all written in PHP, tech that is now effectively 10 years old, onto the cloud. Node was our language of choice, onto Lambda, a lot of it, and it works brilliantly. So how do we know, is there something we know about? We've done a lot of this stuff for years, and what we actually did way back when we first started using the cloud 6-7 years ago is we realized that AWS, and indeed all the cloud providers, they are brilliant, but it is complex to get it right, to understand the networking, right, of the VPC, virtual private cloud, and how to get the security right, and and so on is a non-trivial thing. It's exciting to do. It's great as an engineer, but it's quite complex. And so if you've got lots of different teams all doing different things, and they all suddenly need to become experts at how to make cloud stuff reliable and secure and scalable and things, well, that's going to be an awful lot of effort. So one of the key things we did is we said, well, wouldn't there be some great way in which these teams could write their code and then submit it onto a machine and not have to worry about how that machine's set up and let it just run. So what we effectively did before Lambda, this is back in 2014, before Lambda even launched the first official kind of function as a service things, we actually built our own. We put an API in front of it. We had a way of getting data and so on. And then we even allowed these functions, as we didn't call them that then, that's what everyone calls them now, to call each other in a way that you often get with serverless now. So you ended up with lots of teams building lots of components, not having to worry about the infrastructure, and also being able to use each other's, right? So if you had one team that wanted a system owned by another team, classic microservice, REST API, right? But here you weren't even having to worry about any of the kind of hosting or access control because it was all part of the system, and it works incredibly well. And so when Amazon then came along with Lambda, and of course Google's Cloud Functions and Azure Functions came along as well, we kind of thought, we know this is a good idea, and we've seen some of the challenges that come into that as well. I won't go through all the words, but this also kind of really brought home when we were very lucky to have Simon Wardley come and speak to us in 2016. If you don't know Simon Wardley, he is very good at predicting the future. He has this very useful tool called Wardley Maps, if you haven't heard of it, which is just fab for helping you understand where where you should be focusing and where you're perhaps doing things that now look like they're commodity, and you should be getting, you should be just buying off the shelf. Super useful tool. And he predicted back in 2016, 2017 that the whole world would be overtaken by serverless by 2025. And I thought, really? I mean, we'd used it, we'd loved it, but think of the monoliths, think of the technology, the code we'd written over the years. Yeah, think of Exchange Server or Hadoop, or all these things. The idea that everything could be serverless within a decade, it just blew my mind back then. And what was that? So 3 or 4 years on from that, or halfway-ish to that moment, I think he's right. I think we will get to the point, at some point in this decade, where the idea of servers, of even virtual servers, right? The idea of provisioning a thing will just look daft, will look old-fashioned. And it's still slightly mind-blowing, that, right? But it is going that way, as kind of Sam said. And it will increasingly be the standard way of working if it's not already. Why? Again, Sam said this really well, but don't solve what's been solved elsewhere, right? That challenge of running virtual servers, which is harder than you think, all of keeping the operating system up to date and keeping it secure and reliable, and for us, scale is massive. We have huge amounts of traffic, huge amounts of content. Even just like BBC Weather, for example, has tens of thousands of different locations. We get millions of weather updates every hour. Things like serverless are a great way of handling all that. Maybe not for all use cases yet, but I was a bit more bullish than what was said in the previous talk. I think what I encourage to my teams is do a serverless by default approach. Assume you can do serverless as a start until you've proven it's just not a good idea. Don't get too tied up with the traditional ways of working where you've built a machine or a container or whatever. Try to default to serverless where you can. I'm an architect, and the thing that really interested me was, what does this mean from a software design point of view? Right? So the cloud providers will try and make their serverless stuff better and better, and we can have a debate about whether they've got there enough, whether it's right to let go of that control in return for more freedom, more ability to focus on different things. But what does it mean from a design point of view? I think that's a really fascinating question. And there are 4 areas that we might be able to come into today if we have time. How are we doing? We're not doing too badly, are we? 4 areas. We're going to look a little bit, and again, Sam touched on this a little bit, the idea that the components you deploy as into a function as a service are smaller than microservices, but nor are they the functions that you would call today. So that's function word's a bit weird. I have in previous talks used the word nanoservices. I don't think that's a term that will pick up, but it does at least help understand that idea that it's smaller than a microservice, but not quite the function as we know it. I'll talk a little bit, again, Sam did this a bit, but talk a bit about serverless drives us to functionless in an interesting way. The idea that actually serverless is much beyond the FAS service itself. We'll touch a bit on cost, because this idea that is serverless an awful lot more expensive than just running a container or an instance. Yes and no, we can look at that. And if we have time, we'll go on to request versus event versus request driven, push versus pull, because that has an interesting effect in this model as well. So let's look at that big one. And there's always the obvious architecture joke, right? So how do you design a monolith? Well, that's very easy. It's one box, right? And then you charge your commission fee, right? Let's say we're making an online shop, right? It's obviously you wouldn't quite do it. So bluntly, but a monolith is one big system, of course. Whereas your microservice is a multiple systems, right? I've just made this up for a shop, but you'd have a web interface, right? And a way of handling users and a shopping cart and so on, wouldn't you? And of course, within them, you then have, let's say these are all connected together via REST API, as is fairly standard, right? Let's say that each one had a set of different REST endpoints. Like users might have create user, for example, right? Or update your details, update your address, or maybe some preferences, right? Again, making this up, right? But you would imagine, right? If you were building a microservice for handling your users of your shop, that you would do something like that. We found that level is a really good level. Those individual REST endpoints is a good way of defining what your function should be. Not always, but typically the way that things like the access, like GCP's Cloud Functions, it's normally a one-to-one link between the URL and the underlying function. And the same with something like API Gateway, you can be more clever in Amazon, but fundamentally, the most common thing is whatever one address, one URL goes to one function. And so this becomes a natural way of splitting up. And it's quite a good level because you're not splitting it too fine-grained, as Sam was saying, into individual kind of 5-6 line functions, but you are going smaller than the kind of classic microservice before. And each thing can do one thing really well. And we found for doing this 6-7 years, this is a really good sized piece of thing to build, to think about from a deployment point of view and an operating and a sharing point of view. They are flexible enough that you can change them over time without worrying too much about updating a whole microservice or worrying too many dependencies. And of course, you could do this for the whole life, right? You could go through your set of microservices, look at the endpoints, and as a first level, we think that works quite well for how do you then make your functions. And so, what is functions as a service? Serverless functions. Well, it's that basically. Your design then becomes that, and again, repeat from the previous talk, you can still feel they're naturally blocked, right? Because the problem is, if you try and draw this out as an architecture now, you end up with lines like that, right? Because everything's talking to everything else, and that can like confusing. You do ultimately have more components, right? You are going to have more of these serverless functions, and that's going to get interesting because you're going to have all these things to worry about. What version are they on? How are they doing? How are they monitoring? How are they dependent on each other? So you do need to work on that. But the benefit we found is to be much better, right? These smaller, safer deployments where you're making a smaller change and you can more easily reason about them in a way once you've got your head around all these different bits because they are doing a simpler thing. Here's an example. This is a couple of years old now, this screenshot, but doesn't matter, so we've got the same page now. This is a page we use on the BBC site for doing live coverage of any event, to be honest. It was used for the elections, the UK elections a couple of weeks ago. It's been used for like covering the proms. It's a very flexible page. In this case, it's a cricket match from a couple of years ago. And because it's so flexible, it needs to do a lot of different things, right? And the team responsible for understanding, for example, cricket scores, that kind of little banner at the top and the innings on the right, of course, will be different from those who understand election results or maybe the video or something. So we have lots of teams collectively working on this page. And so what we've actually done is we said that each bit of the page that's kind of drawing on here is rendered as a separate thing. Now, in practice, when we do this, we then put it together into one function because we wanted to be able to render all as one React thing. But it's the same principle. You've got different bits coming together. And so what you get is that page being made up of several separate functions. And then they call their own APIs, which are also cloud functions. And they may also call other things, right? So take that second one, the cricket score has an API that might call something about to get the team information and get something about the latest score from different things. Again, they are all functions. And so you end up, you can see quite a lot of functions going on to make that page, both for the front end, for the rendering, and the back end for the API. And you do have to be careful how many layers deep you get, because it begins to get quite expensive at that point. And that balance between smaller than a microservice, bigger than a function, is tricky to do. But we do find that actually lots of small lambdas, in our case on Amazon, generally perform better than one massive lambda. This is actually the full diagram of that live page. Pretty mad, huh, right? So that first one there, that arrow is the page itself, and then it splits into all of the different components you saw, and then behind that, all of the different data bits in order to do it, right? And as I say, it covers all kinds of things. So no page would ever do all of that, right? They'd all do a fraction of it. But as you can see, as well as the challenges of diagramming this stuff, right? You can never follow those lines. You can also see it does get quite interesting. It can get very interesting if you take it to scale, the number of things. But beyond the scariness of this diagram, what you have is these very independent things that do one thing well. So they are a really good thing to reason about. It's just a little scary when you get to that level. And we perhaps went a little bit too far with this, given this is just one page. We perhaps went a bit too far down the route of making it small. But don't be too scared of it. I don't think it's that many levels off being right. Because as I say, those small units are actually very powerful. So yeah, serverless will mean you have these smaller units deployments. You will have more of them. And you could call them nanoservices, smaller than microservice. That is a tricky dependency management. So we have learned over the years through a bit of pain, have a clear contract if you can of what they're providing. Don't version them if possible. Try just to have one live. Don't go too small, as we've said. And you may need to build some tools. I think we're a bit immature in this space of tools to help understand these different systems. So that's that one. How are we doing for time? All right. Serverless and functionless. So again, repeated a little bit. In the Amazon space, and it's the same pretty much in the Azure and Google space, you have the fast solution, Lambda. But you also have a whole bunch of other serverless one. Fargate being the one that runs containers for you in a managed way. Amazon calls as part of the serverless family. I think it's not really fair, actually, because you still have to instantiate the container. You still have to say how many containers you want and whether it should auto scale or not. So I don't think it is truly serverless. You still have an instance in a way. So I think that one's kind of cheeky. Google has got Cloud Run, which is better at this. You give it your container and it will instantiate it automatically based on requests coming in. It's unbelievably fast and impressive as well. Yeah, then again, as we said before, you have SNS, the notification service and the queuing service and the databases. Even Aurora, as again, so I mentioned, it is unbelievable how that works, right? The way you no longer say you no longer need a database server, right? You just need a database, and it looks after that, and that difference is huge, right? There's loads of them. They're launching more. I'm sure at reInvent when in a few weeks' time, Amazon will launch even more of them. It is serverless by default for them as much as for us, right? The idea of provisioning an instance of something is looking increasingly daft when you have all these things. You know, if you have some messages, you just give it to the queue. You pay for every message. You never worry about how many queue servers are underneath. They're there, of course, but you never have to worry about them. What you can do with this is you almost get to the point now of not just serverless, but functionless, which is where you can actually build an awful lot without writing any code or writing very little code. Because these blocks, you tell them what to do, and they'll do it all for you without you having to write stuff yourself. Let's take a really simple example of a photo gallery app. Ever since Google Photos decided to start charging people, maybe it's time to build a competitor gallery app, right? Let's do a really simple architecture of what that would be, right? The first thing it needs to do is be able to get images, right? So in an Amazon world, you'd use its CDN, CloudFront, and in front of its obvious file store S3, right? That's an obvious thing, right? So you've then got a global CDN and an underlying infinitely scalable file store without a single line of code, right? You can configure all that to happen without any lines of code. Let's say we need to put some image, right? So we need a way of kind of uploading, letting people upload images. So there's an API gateway, which Amazon will offer. Again, you don't need to write code for that to happen, and it can write straight to S3 when somebody puts something. Again, no code required for that. Now, you probably at this point are going to have to write some code, right? Because you're going to need something that to be triggered off that, right? You go, oh, look, you've uploaded an image. I better do something with that. I better check it maybe, and then put it in that main bucket so that you can get it. You can look at those images in the future, right? And maybe you want to write it into a table of things so you can keep a record of all these photos, right? You can imagine something like that. So, okay, we need some code for that. But still, right, that as you know, Dynamo is completely serverless, infinitely scalable. In theory, it doesn't always quite scale to that many peaks, but it is serverless. It's there. You use as much as you need of it. Let's say you also want to send notifications, right, when new photos turn up or something like that. Not a problem, right? Amazon's notification service can send mobile notifications. It's not the best, but it can do it, right? And again, you can configure this stuff without code in theory. Not always mature enough, but you can see where it's going. Maybe you want to be able to access that Dynamo database, get the interesting kind of metadata about your photos. No worries, let's be trendy, use AppSync, a GraphQL service that Amazon provides. You do have to write some code at this point, but it does an awful lot for you, right? It understands, you can give it your GraphQL schema, and then it helps you contact your underlying database to pull out the right things at the right point, right? And so remarkably few lines of code, you've actually got quite a rich app backend, right? From which you can build that on. And then maybe you throw in a database as well, just to complete it, right? You get the idea. With not much code, you're making rather sophisticated service. And it's early days with some of this stuff. You have to fight a bit with API Gateway, for example, in order to properly read and write from different things. But you can see where it's going. That we're entering a world, in fact, here's another example from a blog post a while back, right, where you see these serverless things all coming together. There's a few more orange lambdas there in that example, so they've written a bit more code, but you can still see lots of multicolored things all coming together, all being connected. Sometimes event-driven, was triggered by things happening. Sometimes request-driven, where a user comes along asking for something. But you have all of these individual components doing one thing really well, and from it building quite a sophisticated system that scales as much as you want. And if you don't use it, if we go back to that previous one, right? If 100 million people turned up and used your photo gallery app, well, it costs you a fair amount in cloud costs, right? But it will scale to it. And hopefully a business model can handle the pricing at that point, right? Whereas if no one uses your app, it will cost virtually nothing, right? It will cost just a few dollars, because that's one of the beauties of serverless. You just pay for what you use. So yeah, this idea of functionless, I think, is really interesting. That we're moving to where we're writing code. Well, today we write code that handles an event, right? You're building an API or a website or handling some feed or data coming in, right? You wait for the event to happen, the request or the data or whatever, and then you handle it. That's how a lot of software is written. But we're now moving to an interesting model. We will slowly over the next few years, where we spend more time writing the infrastructure as code. So we're spending more time telling the cloud what to do when something happens. Like when a file gets written into this bucket, run a trigger that puts it on a queue, that sends a notification, that does whatever. You're instructing the cloud on what to do more, rather than writing the code that handles it itself, if you like. And I use the word infrastructure as code with a bit of hesitation, because of course that is a concept that's been around for years, and it's brilliant, right? The idea that when you're configuring your cloud, that you don't press buttons in the console, that you create a script, or CDK is the latest one that Amazon's got, or CloudFormation, its old one, which is entirely brilliant, to be honest, to help define what you want. And this is going to get more interesting, right? It's going to get more sophisticated to tell the cloud what to do. When a file arrives of this kind, then send it to this queue, or do this, or trigger this, or whatever it is. That's going to get richer and richer. And then we might end up at a point with some systems soon where actually that code telling the cloud what to do becomes more complicated than the code you're writing for your application itself, if that makes sense. Because getting Amazon or Google or Azure's systems to handle your event in its super efficient way that does natively will be more efficient than the code you write. So the interesting thing will be explaining to the cloud provider how to behave rather than writing the code itself, if that makes sense. Remember that list we showed a few slides ago of all those Amazon serverless functionalities? What you actually do, if you now look at the other things they have and go, well, where's its serverless version, right? So Elasticache, which is the name that gives its managed Redis service at Amazon, where's the serverless version of that? I don't know, but it's surely in the works, because they now look odd. The fact that you have to say, I want one Redis instance, or 3 or 4, and I want a master and a slave, or all the classic stuff you have to do with services like that. That now feels odd that you have to do that. You can't just say, I want to read and write some data into a cache. And I'm sure all the cloud providers must be working on it. So, okay, yeah. What about vendor lock-in? This is another thing that can often be asked. Surely the more you use serverless, that they are bespoke, right? There's no open standard for this stuff. Surely the more you use it, the harder it's going to be to move from one cloud provider to another if you fall out of love with it, or they fall out of love with you. Whereas a container feels more transportable, right? And there is some truth in that. But I have an interesting view on this. The better the software, the more you change it, which can feel a bit opposite at first. You kind of think, oh, I'm writing this, and it'll be brilliant, I'll be really good. And if it's rubbish, I'll change it. But if it's great, it'll be brilliant, and I'll use it. Actually, what I find is it's the opposite that happens. If you write something that turns out not to be that interesting, right? You can sit in a corner running on the server somewhere, and it might do its little job, but no one will be bothered about it. If you make something that's brilliant, the requests coming in from customers will be huge, right? And the opportunities you'll see to expand it into other markets or whatever will be massive as well, right? So I find that the more important the software that you make, the more you're going to be continually changing with it. And I do love what some teams in Amazon are saying now, which is that you assume you're going to rebuild stuff every 3 years, because that's just everything is moving so quickly in this world. You can't really predict more than 3 years ahead, and there will be a whole load of changes in technology that means you're probably going to look out of date within just 3 years. So in that situation, you're never more than 3 years away from being able to change cloud provider. Basically, I go all in, whichever your provider is, go all in on using all of their commodity stuff, because often it's brilliant. And if you change your mind and you don't want to be with whatever that cloud provider is in the future, assume you're going to evolve it pretty quickly anyway, for your important stuff anyway. I have worked with some teams who've been reluctant to use anything other than a basic EC2, a basic virtual machine, for fear of being tied in, but you just lose out on so much. Another really simple way of looking at it, right? Take the world's simplest architecture diagram. You've got your cloud provider and then your service built on top of it, right? Using their tools. Over time, the amount of growth that we're seeing from all the cloud providers, particularly the three big ones, is phenomenal, right? There is a multi-$100 billion market growing, even at slower speeds, as was said in the previous talk. The competition is so unbelievably fierce, and you will not have missed that the cloud providers are launching so much stuff. And so you've kind of got to do this with your product, right? What happens is they launch some stuff, and you realize that what you were previously doing yourself now could be just off the shelf, right? Problems you solved before are no longer problems if you're taking it a different way. And you kind of have to keep doing this. If the cloud providers are rebuilding their stuff every few years and releasing stuff, you have to move at the same speed as them, because otherwise they're going to keep on doing it, right? And your competitors are going to build on top of whatever shiny new features they've launched. And if you don't, you're just going to fall behind. So I think it's one of the really curious things about the phenomenal level of competition between the cloud providers is that we all kind of have to move at the same speed as well. We have to keep reinventing to use the latest stuff, because otherwise other people will. That was a bit unfunctionless. And if I just do one time check. So we are a bit behind time. So we may not go to the last one, but let's look at cost. Everyone knows this famous phrase, right? 2 hard things in computer science. We need to change it. There is a third one we've discovered, which is correctly estimating the cloud costs of a new system. It is phenomenally hard to properly understand how much something will cost until you've actually built it. We have spent months with modeling software and all kinds of spreadsheets attempting to do it, but there was always something, be it the networking data out costs or the costs you need the monitoring service or something else. It is incredibly hard to really understand it. It's still worth doing, of course. You still have to really try, because it can at least give you a ballpark figure, but it's so hard to get right. But let's have a look at one thing in particular, which is, and again, looking at Amazon specifically, but the numbers are about the same for all the cloud providers. Is Amazon's function service Lambda more or less expensive than the equivalent virtual machine EC2s? And I think containers, you could kind of say, were more or less the same thing as well. So real back of envelope calculations here. If you've seen the pricing for serverless, it is hilarious. It is 0.00002 per request and another small number for every gigabyte a second. This is Amazon. Google is slightly more per request because you get a built-in kind of API gateway. Azure is actually better value. It's a bit cheaper, but it's not a million miles off, right? They've fundamentally got the same model. And you kind of look at it at first and go, that's peanuts. How is that ever going to cost anything? But of course, that's the magic of calculating things. Say you were an interesting system that required 100 lambdas a second, and of course you need to say how much memory you want. Let's say half a gig. Let's say how long to take. Let's say half a second. Let's say you had that, which I don't think is too unreasonable. Suddenly, that's $2,830 per month. Yes, this is what happens, right? You kind of go, okay, that's an interesting number, right? That gets more fun at this point. So how can we compare that with an equivalent of just running a virtual server on a public cloud? Well, the way the numbers work is for every bit of memory you ask, every 128 meg, you also get a chunk of CPU, for some reason 1/14th. Not sure why. And so this particular example, where that's half a gig, you're getting 29% of a CPU. What this basically means, if you do the maths, if you're running 100 a second, half a gig, half a second, what you effectively need is 15 CPUs and 50 gig in order to handle that amount of stuff. As it happens, Amazon has an EC2 that's pretty much the same, 16 CPUs and 64 gig, close enough, and that costs $616 per month. So straight away, you can see that there is a significant difference, right? 4 or 5 times more expensive to use Lambda compared to the virtual machine. And I think this is a really key point. If you are doing something that's computationally expensive, Lambda is an expensive way to go. If you are transcoding a video, for example, might not be the best option. But another example, it may be a very good one. So say you've got running a regular server that's got some API or whatever, right, that's waiting for traffic to turn up. You'd never run that at 100% capacity, right? You just wouldn't. Whereas that calculation kind of assumes, doing a comparison, that you would. In fact, most servers, right, are running at 10% capacity. Let's say 20% capacity. Let's say you got a good one, right? That's still pretty healthy. You don't want to get really above too much more than that without kind of things, without getting into contention somewhere, or not being ready for a particularly high spike in traffic or whatever. So at 20% capacity, which is still pretty generous, it's about the same, right? 4.5 times, right? Roughly about the same. And so I suggest, just from the back of envelope calculations, that the Lambda cost in practice for a lot of classic servers isn't that far off an EC2. And that, of course, is just the actual kind of hosting costs, right? The actual time you saved from not having to configure, patch, worry about it scaling and so on, of course, is on top, which is why it is often a no-brainer. But be aware of one interesting challenge. Take this really simple architecture here, right, where you've got an API access to a serverless function and some underlying bucket. Super simple, right? Now, imagine one request comes along, right? And so do you see that little graph there, showing over time how much of that Lambda CPU you're using? So initial request comes in and there's a spike, right? Because request comes in, you've got to understand it. But then what's happening is you've got to go and fetch the data from the underlying bucket. And so the CPU will go right down while they're sitting there waiting for a response. And then the response comes back and it goes back up again to process it, whatever, and return back to the user. Now, with the functions, you pay for time. It doesn't matter how much of the processor you use during that time, you're paying for it. You've rented that processor for however many seconds that is. And so if there's a moment when you're not doing anything with it because you're waiting for a backend, you're paying for that as well. Imagine you had a second request that came in at the same time, right? Second request, second invocation of the function, you got the same thing, right? You're paying for another chunk of time, even though you've got a point where you're not actually using the processor because you're waiting for some underlying system to respond, right? And you maybe have a third, right? You can keep going like that. If you've got a lot of things running side by side like that, you're paying for each one individually, which is great in a way, right? You're paying per user. It feels fair, right? It's a nice model. But if you had just put it on one server or one container, you would, of course, had the ability to parallelize those things, right? You would have handled those requests concurrently. And so what would have happened is whilst the first request was waiting for its backend, the second request would come in, right? And you would have room on your server to handle that request as well. So you can see, right, that length there, that red line there, is less than the sum of those other 3 red lines, right? So you are eking more out of it. You'll also notice that red line at the bottom is longer. It points out further to the right, right? Because you had contention on your CPU, you are actually slightly slower as a result. The serverless one effectively guarantees you compute for each request, which can be useful if time is critical. But you can see how it does cost more if your backends are slow. So a key lesson with getting good value out of serverless is don't have your lambdas or your functions sitting around for long amounts of time waiting for backends, because otherwise you're just paying for them. So is Lambda more expensive or less than the CPU? So an equivalent virtual machine? It depends. It really can cost considerably more if you're doing lots of compute. Or if you've got lots of servers, doing very little, just waiting for a moment, waiting for a request, it can cost considerably less, right? It is really hard to model it. But I would try and dispel the idea that naturally serverless is more expensive. But on pure CPU it is, but in practice it's probably an awful lot cheaper, or at least a little bit cheaper. Yeah, be careful about blocking requests. Predicting costs is incredibly hard, as always is. I always like the idea to do your best to stay agile, even with an architecture, right? React to how things turn out. Build first and optimize later, to pick I think it's just a brilliant quote, right? You can overthink this stuff. So give it a go seems to be the best way of doing this stuff. Give it a go, learn. And if it turns out it's too expensive or isn't working, then you maybe consider another option. Right, I'm really sorry. We're gonna have to skip all over the question and stuff. We just ran out of time. There was some wonderful stuff in there. Another time. So very, very quickly. Yeah, as I say, we've got over half BBC website serverless, millions of users coming every day, running mostly off Lambda. It works very, very well indeed. The very high level architecture is we have a gateway that handles the requests, and we have put them on virtual machines, because that same idea of you don't want blocking things, right? That would have been very expensive to do with a Lambda, because it's lots of underlying calls that you're waiting. So that's a great one to stick with EC2. But when it comes to the rendering of the page itself, we use Lambda. And when it comes to the underlying API, we use Lambda as well. It just works so well. And they can even call each other so that you can get individual Lambda calls that each do one thing really well. You don't want to go too far deep with that. And then you have the underlying. We actually have another layer, a data fetcher layer, that does caching for us, that we go back to EC2 for. So do you see how we're picking serverless and not serverless as best in order to get the best value, the best way of working? And we will skip over that because of the time situation. Yeah, I do think serverless is on track to be the predominant way of creating applications. We're not there for everything, but do think serverless first, I would say, in many situations. It's more than just Lambda, it's all of those tools you get. And I do think the functionless paradigm is really interesting. Don't forget there will be smaller parts that they do need careful management, but don't be afraid of that. And do use the fact that they're smaller parts to be able to evolve your design quicker, to try and learn and be much more agile with how things are set up. Right, that is it. I'll be around all day if you want to chat on Hopin. I am on Twitter and LinkedIn as well, as always. Thank you very much for listening. There may be some questions I hear. Is there an official, I don't know, it's the first I've used Hopin. Is there an official way of doing questions? Loads of chat, well, that's good. Thank you all. I will read all that in a bit. Well, I tell you what, I can't see any obvious direct questions, but if I find some, I can try and answer them throughout the day. Thanks so much, guys. Enjoy your day, and hopefully I'll see you in person soon.